Ladies and gentlemen, boys and girls, children of all ages. As we begin with fractions, there are many new things that you have not covered. So as we do this video, there may be things that you don't know, and when I ask you, you may give me a wrong answer. And that is fine, because we learn from wrong answers. Okay, so what we're going to do is I'm going to show a couple problems. I'm going to put the wrong answer, but I'm going to show a mistake that is commonly made, and then I'll show the right answer. So there may not be as much conversation coming from you, but we're supposed to begin fractions today. But I still want to work on our stations and give plenty of time for the stations. So I'm going to try and do a little bit introduction of different things as we begin fractions. All right. So I'm going to start with the problem 1/4 plus 3/8. 1/4 plus 3/8. Now what I see when we begin fractions, and what I saw when you use the mountain math, and which is why I told you to hold on to it and don't turn it in yet, because some people were making the common mistake that 97% of my students do before I teach it. And that common mistake is adding straight across. So if we looked at this and we have 1/4 plus 3/8, this is the common mistake that I see many of my students make. So what I'm showing you right now is not correct. Please remember that. It is not correct. But I want to show you why it is not correct. So if you added straight across, Morgan, what are you going to get? If you added numerator plus numerator? 4. And you added denominator plus denominator? 12. So this is what you'd get if you added straight across. Well, let's see how that compares to 4/12. So we're saying that this right here should be equal to 4/12 if the strategy is to add straight across. Makes sense, right? We good. That's what many of us start off doing when we start adding fractions. We think it's just adding straight across. But let's look at what we get. Morgan did that strategy correctly, but I made her do the wrong strategy, and she gets 4/12. Is that going to work? No. Which shows us, and when we get to working on it, you're going to have some of your own that you're going to have to be able to use. 1/4 plus 3/8 equals 4/12. 1/4 plus 3/8, is that equivalent to 4/12? No. So that proves right there that ain't going to work. But what's going to work? That's a good question, Colin. Thank you. Well, still we want to add 1/4 plus 3/8. But I'm going to tell you, writing it down vertically is very helpful. So if I have the problem, 1/4 plus 3/8. Now Joshua, you said something a few minutes ago. Why can't I add these fractions the way they are? I think it was you. Now, who knows why I can't add these fractions? Colin?
Because you can't add denominator and denominator.
Okay, I can't add denominator and denominator. Anybody else have an idea? Sahana?
I think you need a common denominator.
You need a common denominator. Now, unless you slept through 4th grade, you added fractions with the same denominator, put it away, and you only added the numerators. Am I right? Okay. And you didn't add the denominators, which should have been a clue when you got to that problem. This year we're learning, I can't do that. So when you did it last year, you had to have the same denominator. But I can't change the value. I can't change 1/4. It needs to be 1/4. It has to be. That's the only way. Otherwise, I'm changing the value of the problem. And I don't want to do that. It'd be like I give you the problem 7 plus 10, and you go, nah, I'd rather not do 7 plus 10. I'm going to do 7 plus 3. It's easier. Okay? So we can't change the value. Everybody's good with this is 1/4 plus 3/8. What we have to have is something called the least common denominator. The least common denominator. Which means, and you're not going to, most of you won't understand this right away. Most of you won't understand it right away. But you take your two denominators, 8 and 4, and I know you have a multiplication chart that has 8 and 4 on it. And I'm going to list the multiples, not the factors. The multiples of 8 and 4. So for example, if I went 4, 8, 12, 16, 8, 16, 24, 32. And then I want to find the smallest multiple they have in common. Which is what, Joshua?
8.
8. This is the least common denominator for 4 and 8. Now sometimes you're not going to have the same number here. It is not going to work that way every time. And I'll show you one here in a minute. How you doing, Chloe? Doing all right? Good, good. So now what I need to do is I need to change these fractions so that they both have a denominator of 8, but I can't change the value. The value has to stay the same. So if we look at this addend, 3/8 already has a denominator of 8, so I don't need to mess with that. 3/8 equals 3/8, and I want denominators of 8, but I don't want to change the value. So if I do this, I want to change from 4 to 8, and if I multiply 7 times 1, what is the answer?
7.
7. So if I multiply this by 1, and I'm not an artiste, but that's not bad. And does anybody know a fraction that equals 1? Sahana? 8 over 8. 7 over 7. 19 over 19. As long as the fraction has the same numerator as denominator, that fraction equals 1. And they always do like pizzas for fractions. You did a lot of pizzas for fractions. If our pizza was cut into 8 pieces, and you ate all 8 pizzas, you ate one whole pizza, right? Okay. So I need to multiply by a fraction that equals 1 so that I don't change the value. I'm going to change the way it's written. It's like changing $1 and saying, hey, Colin, here's $1. Can I have 20 dimes? I'm changing the way it's written, but it's not changing the value. Sahana?
2 over 8.
2 over 8. Same numerator. Okay, you're right, but what am I multiplying by? What's my fraction? 4 times what equals 8? 2. So if I multiply this by 2 over 2, does everybody see that 2 over 2 equals 1? Yes. I cut my pizza into 2 pieces, and I ate both pieces. I ate a whole pizza. Then I'm fat and I'm throwing up. And after I throw up, then I'm eating ice cream. I like me some ice cream. All right. So now, when I'm multiplying fractions, you're going to learn this ahead of time. I'm not even teaching that yet. When you multiply fractions, that's when you do it straight across. So 4 times 2 is 8. 1 times 2 is 2. And I can check that. If I take 1/4 and 2/8, I can see they are equivalent. So now, what you learned last year, 2/8, always pay attention to the sign, because a lot of times I get students doing it incorrectly because they used the wrong sign they added when they were supposed to subtract. Now if I say 2/8 plus 3/8, I'm going to get 5/8. Now I can check that. 2/8 plus 3/8 is 5/8. This is our original problem. 1/4 plus 3/8. I think the answer is 5/8. So I'm going to check. Here are 3/8. Here are 2/8. Are those equivalent? Yes. So I can find the common denominator that way, using the least common denominator, and I can add these fractions like that. Are we good? Okay. That's good. Like I said, it's the first time you're seeing it. A lot of times when I was learning to drive,
that was way too much information.
Yes, especially when you were sitting using your phone.
I wasn't.
That is too much information. So let's take the problem. Let's go 1/3 plus 2/4. Can I add those the way they're written? No. Why not? They have a different denominator. I need to make them have an equivalent denominator because I can't add or subtract fractions that have different denominators. So I'm going to find my least common denominator. You guys are so lucky. You're going to get this stuff ahead of time.
Yeah.
Man. Least common denominator for 3 and 4. Anybody have an idea what it might be? Okay, I've called on Sahana and Joshua 17 times. Izzy.
12.
It might be 12. Let's look. 3, 6, 9, 12. Izzy thinks it's 12. 4, 8, 12. And Izzy is correct.
Wow.
My least common denominator is 12. So let's set up our problem with the fraction pieces. I have 1/3 plus 2/4. I think my common denominator is 12, so I'm going to use my 12 pieces here in a minute. But I have to have a common denominator before I add them. So I have to add by a fraction that equals 1, which means it's got the same numerator as denominator. So 1/3. Natalie, what am I going to multiply? 4 over 4. I choose that because I know 3 times 4 is 12. I mean, I could choose anything, but I'm not going to get my denominator of 12 then. Okay, she chose 4 because she just looked at the denominator. 3 times 4 is 12. So she knew how to get to 12. All right, Kaysen. What is my fraction that equals 1 going to be here? 3 over 3. Okay, so I'm trying to equal this. I said it's the denominators of 12. Now my numerator here, Maribel, is going to be what? 1 times 4 is 4. So I think I'm going to use 4/12, which is equivalent to 1/3. My numerator here, Alize, is going to be what? 2 times 3 is 6. Is going to be 6/12. There's 3 and 6. Anybody have a problem saying those are equivalent? No. It's an addition problem. So I always make sure I circle that. And then I have Sanaya, 4/12 plus 6/12 equals You're just adding the numerators. 4 plus 6 is 10. Good. And the denominator stays the same. 10/12. Anybody have an idea? Anybody simplify fractions? You guys simplified last year, right?
No.
No? Okay. Sahana?
5/6.
5/6. And we can check that. And I'm going to show you later how she got that. But this fraction would also be equivalent to 5/6. And we'll talk a little bit later, maybe next video, how to simplify fractions. I probably did that kind of backwards. I should have simplified before, but that's fine. Okay. If you're still confused about it, we're going to continue fractions. We do fractions all the way into December. So we got a lot of time to work on fractions. Not difficult. Every one of you, it's a lot of steps. Let me put it that way. You can find at least a common denominator. Pretty easy. You can list your multiple. You can use a multiplication chart for that. Once you find the common denominator, I can put times 1, times 2, times 3, times 4. It tells me that 3 times 4 equals 12. It tells me that 4 times 3 equals 12. So once you change those and we have a common denominator, and we start with fraction pieces, so that'll help. Then you just add the numerators. That's important to remember. This is the important parts of it, is you have to have a common denominator, and you do not add the numerators. Boom, shakalaka, peace out, God bless, love you, do something kind today.